Where's I got the one pity point circuit?
The pity point?
In circuits, I got a question completely wrong. And she gave me +1. And I was like, why'd I get it?
Oh, it's a pity.
She goes,
Oh, okay.
I completely messed up.
Oh.
Yeah,
Oh.
I didn't even remotely get it right.
Well, you know, pity points. You take. I never thought about pity points, but
Well,
yeah.
it's funny. Well, that's just how I thought of it. But I
Yeah.
was funny because Jake was sitting right next to me. He got a 24 and I got a 25, and that 1 point was the pity point.
Oh, there you go.
Because I only wrote one equation and she gave me a +1, and Jake like did this whole page where then he got -4 points, and he was like, "What about my effort?" I was like, "Not as much."
All right, so we did this part from last time. We started with this crank, and I wish I'd have drawn a better crank than that, but it's just a line, it's a piece of metal, a bolt right here, and you know the piston goes back and forth. So what we did is we came in and found the velocity of that point and then the acceleration of that point.
You did this one?
We did this on Friday.
I didn't know if you were just going back over it or.
Well, what I was going to do is set up, because then the next thing I'm going to go from B to C. And so now you can kind of see why you don't want to do these in an in-class test. They take a long time. And now if I had Tuesday, Thursday, which would be better, you'd have an hour and a half for a test, but an hour or 50 minutes is not enough. So, so anyway, we did this. We came in and did our accelerations. And we got that. And I think that's where we stopped, although I had one more row. And then I wrote that down. Now, I kind of regret picking omega to be 10 because that made these numbers big compared to these, but it doesn't matter at this point. So the next key is I have the acceleration and the velocity. Of course, I got to put them together. Got to put these together and this one together. But I got the velocity and acceleration at point B. And since B exists in one link and the other, it can be used to work on the second one. Now, what I did is I went in and recopied. I basically selected all this and recopied the exact drawing here. I mean, it doesn't look good, but one of the things I'm going to need is I'm going to need the vector that starts at B and points to C. And when I have that, of course, the way I did this is it's 4, 3, and this is 15 over, but it's aligned with this. So 15 minus 4 gives me 11. And if it went up 3, then to go back to 0 has to come back down 3. And so you have a vector that draws from here to here. So then what I did is I said, okay, velocity of C is equal to velocity of C relative to B plus velocity of B. Now, that I pulled up from before. That was Friday's thing. Then what I did is I said, hey, wait a minute, omega BC times R C to B. Well, okay, now I could do this instant center, and I kind of drew it right there, instant center, but we'll scroll it up in a minute. For the time being, I say, I don't know what omega BC is, but I'm going to assume positive. X to Y gives me Z. I'm always going to assume positive, so I put it in there. This comes straight from here. You mean this thing? Or are you talking about on the link?
Yeah.
Well, you know, the way I try to do it is I always try to make everything go in the positive direction. And then I worry about it when it comes off. Because if I'd assumed it to go negative, I just have to keep up with that. So I'll have to say, oh, I assumed that one to go that way. Often you can get confused in the problem. Which way did I assume it? And to me, if I always assume everything positive, like right here, I assume the velocity going to the right is positive. But this thing's rotating back this way, so it is going to the left, but I don't care. I assumed it to go positive X direction, and we'll see that down here.
You can.
Yeah, you can. And I just always choose to make everything, if I have an X, Y coordinate, I always make all velocity. If I have to guess a velocity in the x direction, I'll guess it to be that way. If I have to, right. I can just say, oh, it was always referenced back to this on every problem. And I don't have to worry about it. So to me, I like to do that. Now that's something that probably comes from a physicist kind of back point, because the physicists generally do that. You know, when they get into math, they'll always assume everything's going positive. Then if they do that consistently throughout their whole career, then it's easy. They don't have to worry about that. And that's kind of what I ended up doing. And this has been with me for years.
I just know when I look at the problem and say, like, I'm not going to do that because it should be done. I'll be like, I know this one's going that way, but I'll try to figure out the other one.
Yeah, and if you do, just put a box around it so you remember what you assumed. So I'm not saying, but when you do, you'll want to reference it back to what your assumption is. So if it came out negative and you were like, oh, crap, that's wrong, then you go back and you can, because this one is a little bit difficult. Actually, as this goes up, this is going this way. So it turns out this thing's rotating around the other way. Instant center comes right here. If this is going up, this thing's rotating like this around that instant center. So the instant center would help, you know, if you're going to make those assumptions. But to me, I'm just going to do it this way, you know. Then I can sleep, you know, I can sleep through this. I can sleep through everything. So I copy these down 3 times. Take the I, this times this minus that times that gives me this. That times that minus this times this. But it was already a minus because it was on J, so I get a plus. To check it, I take this times that plus this times that. It turns out they cancel out and go to 0. So in fact, this is perpendicular to that. So I'm pretty comfortable that this is perpendicular to that, has to be. And by this is always perpendicular to this one, because that doesn't tell you anything. So when I get that, let's see, I go and I rewrote it. I don't know why I rewrote it. Oh, I know why I rewrote it. Next thing is I went in and assumed. I said, well, okay, this is me with my positive assumptions. X is going that way. I'm going to assume it to go that way, even though I can look at this instant center drawing. And you and I can both tell I'm wrong in my assumption. Things rotating like this, so this point's going up. This point's forced to go that way. It's going like that. And I'm assuming it to go like that. So I'm assuming it to go the wrong way. Well, the other thing, wait a minute. This, okay, if it's going like this, okay, let me rephrase. If it is going like this is going that way, not that way. I don't care. I'm assuming it anyway. Because at this point, I was here in the problem before I got here. So I got all the way down, I solved it, then I went back and did this. So I just did my standard assumption, grunt and grind. Put that there, pull the VC out, the 3 omega, minus 30, put a 0 because there's no J, 11 omega VC, and 40. Move one under, and lo and behold, I assumed that it gave me that. So it gave me a negative number. Now what's funny is the physicist won't reference this back. They'll just leave it as a negative number. And so a physics person will always use those coordinates and spout negative numbers throughout everything they do. They don't reference it back. And that's just the way they do. And then I took this, stuck it in. I actually stuck it in there and then pulled it down here, figured it out, and it's going minus 40, which is going back. So if this thing's going that way, it's pulling that thing that way. So physically, it makes sense. So we got omega and we got the velocity. We're less interested in, we don't need particularly this one in the next phase, but we do need that one. Because now I want to find the acceleration or the alpha of that link, and I want to find the acceleration of the piston. Actually, that's kind of important because F is equal to ma. If that thing is pulling it back that way, You just multiply times the mass of the piston. Now, okay, you and I both know there's probably going to be a force due to combustion pushing that thing back. But if it was just being pulled back by this crank, you know, like a compressor, say, you know, so there might be other forces on there. So the next step was I went in and I said, let's do the acceleration. And did I redraw it? I don't think I did. But I could put these points on this thing. I could say this is A. Oops. This is A, this is B, this is C. Now, that makes that helps a little bit. Acceleration of C is equal to the acceleration of C relative to B. This one, and so the alpha will come in and the omega. Acceleration of B, which I have that not here, but the line up there above. So I have this actual, and I didn't want to copy it down, so I just said later, I'll do that. I'll add this later. And so then I realized, oh, I should have put this equation over here, and I have all this stuff. So the acceleration of C is equal to alpha BC or CB. It's just the alpha of that link. That's basically whether the link is spinning up or slowing down. You know, it's going at omega. Is it going faster or slower? You know, meaning that it, you know, it's accelerating. This one is the fact that it's the centrifugal part, and this omega BC is something we found there. I don't care whether it's plus or minus. That part's minus. This is squared. Doesn't matter. This vector is the same vector that was up in that last problem. And this is why I like doing it this way. Let me shrink it down. I can show you. So if you shrink it, maybe shrink it twice, the typeset gets kind of small, but here's what I like about this. So I've got to do this alpha R. Did I? Oh yeah, there it is. Okay. So this one looks a lot like that one here. Used to have a big long, I broke this, but that's okay. This one looks a lot like that one. As a matter of fact, that, and then the omega's here, but alpha's there. That one's exactly the same. 11 minus 3 and 0. 11 minus 3 and 0. Me, I'm a big proponent of if you can find a way to make things simpler, do so at all costs, as long as you don't give up your ability to do things. I think this widens your ability to do things. So in fact, what I did is I said, hey, I know if I multiply this one out and that one out, this is going to look a lot like that one. So why don't I just copy that down, change that to alpha BC, and that's exactly what I did. 3 alpha BCI, 3 omega BCI, 11 alpha BCJ, and 11 omega BCJ. I just copied it. Now, this part, that doesn't. So what I did is I stuck this in here, squared it. Well, then I multiplied times 11. I threw away some digits. In the middle of it, I thought, wouldn't it be great if everything came out to be an integer? But no. So I got this one, and I got a minus that one, or plus that one. And it turns out that's like 39 and a half, roughly. There were some more digits. And finally, I copied that. Okay, so what I had to do was I had to go up there, and I was just, okay, got to shrink it even more. Okay. So what I did, went up and took the 6 and the 400. I got that from Friday. 6 and the 400 give me 406. 300 minus 8, I hope that's 292. And so I just copied that. That's what you do when you get the link. When you get this, and when you're on this link, you can get it, velocity and acceleration here from the last problem. You just copy them. And once you copied them, you're good. You have that together with this, And so, oops, wrong way. So then what I did, all you do then is you just say, okay, I'm going to extract the I's, A3 alpha, 145, and the 406. And I think I did this right. So 5, that's 11, 4, that'd be 5, and then 5. Okay, so this one, so you got two unknowns and two equations there, but luckily J has nothing over here, has this right there, and then the 252. So I took that. I hope I did that right. So it's minus 252 is what I got. Then I swiveled around there and ended up with two very interesting numbers. And what I ended up with is I ended up with alpha being, well, it was 23. I think it was 22.8 or something. So I just made it 23. And then I stuck it in this one. So I took 3 times that minus 551, which ends up being minus 482. Now, this is where I stumbled a little bit. Here's how I stumbled, okay? So I assumed the velocity was going to the right. It wasn't, it was going to the left. I assumed acceleration was going to the right. It wasn't, it was going to the left. So both of these are going to the left. The minus sign, you got to think about that for a minute. So that kind of means that the velocity of the piston is whatever it is in so many other feet per second, but it's also accelerating. It's going faster. And when I looked at the problem, that's when I drew this problem. I didn't finish drawing it, but I started looking at it. I started thinking, well, if this thing is doing that, and I think, okay, let me check this. Yeah, I got that with omega and that doing that. Sort of makes sense that this thing would be going that way, definitely with a velocity and also an acceleration. So it's going faster. So it's picking up speed. The piston over here at C is picking up speed. So that's essentially all I did, I think. Of course, I took longer for them than I did for you because I spent the time writing it out. But if you think about it, I mean, to me, working them this way is very convenient because, one, I don't have to, you know, in the book, he'll do this J cross I, and, you know, and he'll have this written. He'll have the omega, you know, cross R something to something. And then he'll always have this being, you know, like omega times K crossed with, you know, 10 I plus 5J. And then you got to think, oh, wait a minute. Okay, what is K cross I? Okay, wait a minute. And then I got to, to me, I'd have to do like this. I, okay, and J, and then K, okay. So if I cross that, okay, now if I cross K cross I, okay, K cross I, that's going to be J. And then if I cross K with J, that's a minus I. So I got to think like that. And that I don't like. I don't like to have to stop in the middle of the problem and see that. Plus, I see no, this way, I see no structure, or let me rephrase that. I do see a structure. It's more difficult to find the structure between this and this one. To me, I find that a little bit more difficult. Now, if you're used to working it that way, by all means, and you feel comfortable and you feel like you can do it better that way, by all means do it. One of the things I have found over the years, off and on teaching this, is that people who generally do it that way tend to make more mistakes on an exam and stuff. And I'm not sure exactly why, except if you think about, you know, in the way you think when you work a problem, especially on a test, as you get stuff and you work it, as you're thinking about what's coming next, if you have to take a side issue and think about something else to do the math and then come back, you got to pick it up where you were before and think about, well, where was I now? Versus that way, to me, it's just like, oh, plug and chug. I can look. I don't have to take that mental break for a few seconds.
More pressure to find the answer on an exam or something, so the more options you give yourself.
Yeah, yeah. And that's the thing. I mean, testing is a very difficult and interesting subject because sometimes people might not score very well, but yet know the material. And then other people I've seen score better, but show, you'll look later and you'll think, wow, I don't think they really got it back then. So how do you make a test that covers that? That's a hard thing to do. And there are people that theorize on all that. And I don't know. And to me, I'm just trying to get through the material, get you through it, and then go on about life as it comes to you. To me, I find that to be a more fruitful task than the nit and pick about picky nitty things or nicky pitty or whatever. Nitpicky, yeah, that's it. I couldn't get it together there. Yeah, it doesn't make much sense.
Don't worry about it. I can't keep on like
You know what? You'll spend your whole life trying to get your life together, and then you found out, well, I didn't spend as much time living it, so I better just say, oh, well, crap, just go with it. I tell you, you'll be my age and you'll be still trying to get it together, and you'll be thinking, oh gosh. So it's okay. It works out. Just go make sure you have fun at it, whatever you do. That's the key. Because life without fun isn't very fun, Yeah, yeah. So that's all I did there. I think what I'm going to do to everybody is I think I'll come up with and I told them that's actually, now that I think about it, that's why I drew that picture right there. I was telling them I'm going to draw the picture for them on the test, but I'm going to try to make it look like that instead of my lines. So that, even that, I mean, I may even go in here and do silly things like this, in other words, make one link, like, okay, here's one link, and then there's the other, like color code them or something, so that they're different links and they operate differently. So
is that going to be on first test next month, or is that going to be on
that's going to be the take home. These will be the take homes. So really what you want to do is maybe I shouldn't give that test until we deal with the test in chapter 12. You know what I'm saying? In other words, split the midterm into two parts. First part be the in-class part. Give you the other part. You could take it home with you and turn it back in a couple weeks after spring break. Then that way you're working on that part after you're working on. So I think maybe I'll do that. I don't want, but everybody seems to schedule their time pretty well. So maybe I could, if I make it up, I could just give it to you and say, oh, this is not due till a couple weeks after spring break. So focus on chapter 12 first.
Well, the thing is, like, no matter when you give it to us, dude, it matters.
Yeah. I would feel bad if somebody took that test and worked it for the Wednesday and didn't study for 12 and then came in here, I got that part done. Yeah. So if I do it, I'll be very specific about that. So
I feel like at this point of year, like most people are in this class, we know how to look at their time.
yeah. Well, and then the other thing,
Quite a bit of it. So.
and what, yeah.
Exactly.
So the second half of this course, which is after this part, you'll kind of find to be a little bit downhill because there's a few interesting things along the way, but nothing this difficult. This is actually the most difficult part right here. When we get into some forces equal MA, you'll look at it and you'll say, okay. Then when we do energy, you'll say, oh, that was easy. And then we do impulse and you'll say, oh, that was interesting. And then by that time, you're pretty much finished. And so I'll pick up a few things along the way. But I'm not going to test on, I'll tell you when I'm not going to test on those particular items. So I don't know.
We need that extra power.
Well, and mechanics materials has 2 courses after it, machine component and fundamentals, and I never quite got which one comes first. But anyways, one comes first, one comes second. Oh, does it? Okay. Yeah.
Pretty sure I looked at the schedule for next.
Oh, did you? Oh, okay. I can't.